Good day everyone! Welcome to another video lesson in Technology and Livelihood Education, ICT CSS Grade 7 and 8. Once again, I'm Teacher Grace J. Villena. Before we go to our lesson, let's have a review. Choose the answer from the given choices. Are you ready? Let's start. First one. Achieves containing basic instructions like booting the computer and loading the operating system that can be directly accessed by the CPU. Is it RIMM or RAM Bus Inline Memory Module, Random Access Memory or RAM, Read-Only Memory or ROM, Storage Drives? Start. The correct answer is read-only memory or ROM. Next question. It is volatile temporary storage for data programs that being accessed by the CPU and the contents are erased when the computer is powered off. Is it RIMM or RAM Bus Inline Memory Module, Random Access Memory or RAM, Read-Only Memory or ROM, or Storage Drives? Let's start. The correct answer is Random Access Memory or RAM. Next question. It is the newest and the most versatile type of storage for computers. Is it flash drive, optical drive, cloud storage, or magnetic storage? The correct answer is cloud storage. Next question. A storage drives use read or write heads, electromagnets that detect or read or change or write the magnetization patterns on the disk. Is it hard disk, flash drive, optical storage drives, magnetic storage drive? What is your answer? The correct answer is magnetic storage drive. Next question. A storage drive that uses laser to read the reflections in the disk or burn the data pattern into the disk. Is it optical storage drive, hard storage drive, flash storage drive, or magnetic storage drive? The correct answer is optical storage drive. If you were able to answer everything correctly, congratulations! Now let's move on to our lesson. For this video, we are going to discuss the part 1 of lesson 2, decimal to binary conversion. So, learners are expected to identify how to convert from decimal to binary, convert numbers, strengthen and reinforce skills in conversion through participation and activities in the video lesson. Now, computers convert all the learners' numbers and special characters that we type from its keyboard into series of ones and zero, so that it will know the data and process it to provide us a meaningful and useful output that is converted to the language that we understand. In a computer, information is represented and stored in a digital binary format. The term bits or bit is an abbreviation of binary digits, which represent the smallest piece of data in a computer system. Bit. A bit can have only two possible values, which is a 1 digit or 1 or a 0 digit. So for example, we have for decision making, we have true or false. So the answer is either true or false. If you're going to switch the light, you're going to choose on and off. So the only possible answer in the bit is 1 or 0 only. So a bit can be used to represent something that has two states. The ASCII computer uses binary code to represent and interpret letters, numbers, and special characters with bits. A commonly used code is the ASCII, or the American Standard Code for Information Interchange. So each group of 8 bits, such as the representation of letters and number, is known as byte. So 8 bits is equal to 1 byte. Codes can be used to represent almost any type of information digitally. Computer data, graphics, photos, voice, video, and music. How are you going to convert decimal to binary? Let's begin. So, it's important to be familiarized with the power of 2 table. Any number that is raised to 0 is equal to 1. And 2 raised to 1 is equal to 2. 2 raised to 2 is equal to 4. 2 raised to 3 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5 is equal to 32. 2 raised to 6 is equal to 64. 2 raised to 7 is equal to 128. And 2 raised to 8 is equal to 256. Now, how did we get 2 raised to 0 is equal to 1? 2 raised to 0, so 0, automatically, its equivalent is 1. As 2 raised to 1 is equal to 2. 2 raised to 2 is 2 times 2 is equal to 4. 2 raised to 3, 2 times 2 times 2 is equal to 8. 2 raised to 4 is equal to 2 times 2 times 2, and times 2 equals to 16. And so on and so forth. converting 25 to binary, we are going to check this one. So because 256 exceed to 25, we are going to look for the highest base number and less than 25, and that is number 16. So we are going to start with 16. But before that, I would like you to know that there are two methods of conversion. So we have the subtraction and division method. So 25 is equivalent. We are going to use the base number and less than 25 is 16. So we will start with 16. So 25 minus 16 is equal to 9. And the highest base number less than 9 is 8. So 9 minus 8 is equal to 1. And we're going to write 1 on that part. So 1, we will start on 1. So if we're going to add 16 plus 8 plus 1, it should be equivalent to 25. Now, that is our, we will start with 16, 8 plus 1. So ang equivalent nyan is 16 is equal to 1, 8 is equal to 1. Because we don't have 4, so we will, that the equivalent is 0, and the 2 doesn't have 2, so the equivalent is 0 also, and 1 is equal to 1. So our binary number is 1. 25 conversion to binary is 11001. Next, let's try this. Convert 82 to binary. You have 3 minutes. Go. Okay, time's up. If you are not yet done, you may pause this video and just continue on the computation. Now let's move on. So we're going to look for the highest base number and less than 82. So that is 64, and so we're going to subtract 82 to 64, so we have 18. Then the highest base number and less than 18 is 16. Then we're going to write 16 there. 18 minus 16 is equal to 2. So the highest base number and less than 2 is still 2. So we are going to end there because 2 minus 2 is equal to 0. So we have 64, 16, and 2. So if we are going to add that, the result must be 82. So under 64, we're going to have a 1 because we don't have 32, so the equivalent will be 0. 16 is equivalent to 1. 8, we don't have 8 and 4, so the equivalent will be 0. Then we have 2, so it's equivalent to 1, and we have 1, so the equivalent is 0. So the binary is 1 0 1 0 0 1 0. If you get it correctly, congratulations. Let's convert 25, the one that I used a while ago, to binary using the division method. So let us convert 25 to binary. A while ago, we found out that the binary of 25 is 11001. So let's confirm that using the successive division method. So 25 divided by 2 is equal to 12.5. So we're going to write 12, and the remainder will serve as 1. So next, 12, we're going to write the 12 there, divided by 2 is equal to 6. So there's no remainder, so we're going to write 6, remainder 0. Next, 6 divided by 2 is equal to, yes, 3. So there's no remainder again, so we're going to write remainder 0. Next, 3 divided by 2 is equal to 1.5. So we're going to write it as 1, and the remainder will be equivalent to 1. Next, 1 divided by 2 is equal to 0.5. So 0.5, meaning we're going to put 0 and then remainder 1. So this one, the lower part will be will serve as the MSB, or the most significant bit, and upward, the highest part will serve as the LSB, or the least significant bit. Meaning, we will read it upward. So we'll start 1 1 0 0 1. So 25 is equivalent to 11001. So now let's try another activity. So we're going to convert 106 or 106 to binary using division method. So let's start. Okay, time's up. But if you're not yet done, kindly pause this video and continue solving. Now let us move on. So convert 106 to binary. So 106 divided by 2 is equal to 53. Remainder 0. 53 divided by 2 is equal to, yes, 26.5. So 26, remainder 1. So 26 divided by 2 is equal to 13, remainder 0. 13 divided by 2 is equal to 6, remainder 1. So because the answer is 13 divided by 2 is 6.5. So we have a remainder. Next, 6 divided by 2 is equal to 3. So remainder 0. 3 divided by 2 is equal to 1. Remainder 1. So 1 divided by 2 is equal to 0. Remainder 1. So let's stop there. So now let's put the MSB, or the most significant bit, up to the least significant bit. So we have 1, 1, 0, 1, 0, 1, 0. So that's the binary of 106. We get it right. Congratulations. Now let's move on. So reminder that there is a part 2, lesson 2 of conversion of binary to decimal. So you just continue reading your module ASCII CSS grade 7 and 8 for quarter 3 or week 4. And then don't forget to answer the activities, checking of your understanding, pauses, and reflection from your module. So thank you for watching.